Good morning students. So in this class let us discuss about the transformation between Cartesian to cylindrical and spherical coordinate vectors. So there are three types of coordinate system, we all know that. So that is Cartesian coordinates, spherical coordinates and cylindrical coordinates. So already we have discussed about the basic conversion things, and in today's class let us discuss how the Cartesian vector can be converted into cylindrical vector, and as well as how the Cartesian vector can be converted into a spherical vector, right? So for that case, this table is very much needed, and from this table we can do the conversion very easily. So let us discuss how the Cartesian to cylindrical coordinate vector system can be done. So here you can see the table. So Ax, Ay, Az are Cartesian coordinates, and AR, A5, Az are cylindrical coordinates. So Ax dot AR means you have to replace that term by cos phi, and Ax dot A5 means we have to replace by minus sin phi, and Ax dot Az means we have to replace by 0. So like that, Ay dot AR, Ay dot A5, Ay dot Az, and Az dot AR, Az dot A5, and Az dot Az as 1. So this is the table for converting Cartesian vector to cylindrical vector. So like that, the Cartesian vector can be converted into a spherical vector. So for that conversion, this table is needed. So that is, spherical coordinates are capital R, capital theta and phi, and the Cartesian vectors are Ax, Ay, Az. So in case if Ax dot AR means we have to replace that by sin theta into cos phi, and Ax dot A theta means we have to replace by cos theta into cos phi. So like that we have to have this table, and we can replace the coordinate by Cartesian to spherical thing, right? So let us discuss one problem regarding the transformation of Cartesian to cylindrical vector, right? So the given problem is transform the Cartesian vector B is equal to y-ax vector minus x-ay vector plus z-az vector into cylindrical vector. So right, so write down the solution, and the given vector is B is equal to y-ax vector minus x-ay vector plus z-az vector. So this is the given Cartesian vector. This Cartesian vector has to be converted into an equivalent cylindrical vector. So that is the problem given to us, right? So that cylindrical vector can be written like this. So that is B is equal to BR AR vector plus B phi A phi vector plus BZ AZ vector, right? So that is BR, B phi, BZ. Why? Because the cylindrical coordinates are R, phi, Z, right? So that so in this equation we have to find out BR, B phi as well as BZ, right? So to find out BR, we have to take B dot AR. So this B is given Cartesian vector. That vector has to be converted into a cylindrical vector. So instead of B, we can write y-ax vector minus x-ay vector plus z-az vector dot AR vector, right? So take a dot product, so that y into this ax dot AR vector minus x into ay dot AR vector, and then plus z into az dot AR vector. So from that table, from that previously explained table, instead of Ax dot AR, we can write as cos phi, and Ay dot AR is sin phi, and Az dot AR becomes 0. So this term becomes 0. And finally we can get Br as y cos phi minus x sin phi, right? So instead of x and y, we can replace the term x is equal to r cos phi and y is equal to r sin phi. So that this Br becomes, instead of y, we have to substitute r sin phi. So r sin phi into cos phi minus instead of x we can substitute r cos phi. So r cos phi into sin phi. So you can see this r sin phi cos phi minus r sin phi cos phi. So these two terms becomes cancel each other, so that BR value becomes 0. The same way we have to find out B phi. So B phi is P dot A phi. So write the value of B vector dot A phi vector and find the dot product. So that is y into Ax dot A phi vector minus x into Ay dot A phi vector and plus z into Az dot A phi vector. Right? So according to that table, Ax dot A phi becomes minus sin phi minus x into Ay dot A phi. So that value becomes cos phi plus z into Az dot A phi value is 0. So this terms becomes 0. Right? So that the B phi becomes minus y into sin phi minus x into cos phi. And now you substitute the values for x and y, so that you can get minus r sin square phi minus r cos square phi. So take minus r as common, so that you can get sin square phi plus cos square phi. We all know that sin square theta plus cos square theta value becomes 1, so that your B phi value becomes minus r. So now we found the value of BR as well as B phi. And from this equation, by comparing this, we can get Bz value as Z. By comparing to this equation, Bz value becomes Z. Right? So finally, the cylindrical vector becomes, so we know that B is equal to BR AR vector plus B phi A phi vector plus BZ AZ vector. So we found that BR value is 0, so that 0 dot AR plus B phi value as minus R. So from that B phi value as minus R into A phi vector and BZ value as Z into AZ vector. Therefore, the converted cylindrical vector equation becomes minus R A phi vector plus Z into AZ vector. So, from this we can say that the given Cartesian vector is transformed to a cylindrical vector. So like that, for any given problem, we can convert or we can transform the Cartesian to cylindrical vector. The same way, by using this tabulation, you can convert the given Cartesian vector into a spherical vector also. Thank you.